All right, so last class we left off, or we closed out 12.2. So today we will start off with 12.3, probability and odds. So when it comes to chapter 12, there are only 4 sections in chapter 12. So we only have one more section out of chapter 12, and then we'll close that out. So we'll do that on Friday. So 12.3, probability and odds. Turn to notes. So probability is the likelihood of the occurrence of a particular event, and it's always between 0 and 1 inclusive. That means it can be equal to 0 or it can be equal to 1. Finding the probability of your event. That's what that P parentheses E stands for. You say P of E. So this probability of event E is the number of outcomes in the event over the number of outcomes in the sample space. Back in 12.1, we talked about what your event is and what your sample space is. Your sample space is the total number of possible outcomes from your experiment. And then your event is just a collection of outcomes out of the sample space. All right. So let's look at the first example. A single die is rolled or tossed. Find the probability of rolling a 3. So you want to establish your sample space first. And over here was my attempt to draw some dice or a die. So you look at a die, whether you play board games or whatever the case may be, Monopoly. You know there's a sample space of 1, 2, 3, 4, 5, and 6. Also, what I want to point out, notice in our sample space 1, 2, 3, 4, 5, 6, this 6 and this 6 over here, the number of elements that we have are 2 different 6s. They don't have anything to do with each other. In other words, if this was 1, 2, 3, 4, 5 triangle, this still would be 6. That represents the number of outcomes that you have. So make sure that we're not looking at both of those 6s and say, well, since that ends in a 6, then this other number would be 6. That's not the case. Those are 2 different 6s. All right. Once again, the 6 in your sample space is just an outcome. One of the faces of your die. Here is the number of outcomes in your sample space, which is 6. All right. We want to know the probability of rolling the 3. So your event is just a 3. So the number of outcomes in your event is 1. There's only 1 3 in your sample space. So calculating the probability, you will put the 1 over 6. So you got a 1 out of 6 chance of rolling a 3. All right. The probability of rolling an even number, we're still dealing with the same problem, so we do not have to reestablish our sample space. As far as even numbers goes, there are 2, 4, and 6, 3 even numbers in our sample space. So the number of our event is 3 elements, 2, 4, 6. So the probability of rolling an even number is 3 over 6. So you got a 1 out of 2 chance, or 50% chance of rolling an even number. Next, the probability of rolling a number greater than 4. There are two numbers that are greater than 4 that's in our sample space, which is 5 and 6. So 2 over 6 will reduce down to 1/3. Any questions on that first example? All right, let's see if that's a question. Yes, Mr. Stegall. Hopefully I'm saying that right.
Hey, so you know how you said the dice with the six sides, like the probability is, well, the number of combinations you have is six, right? So what if, like, hypothetically speaking, you had a dice of like seven sides? Would that increase to like seven?
Yes. Mm-hmm. Yep. So, if I had a die that had 8 sides, then my sample space would consist of 8 different options, and so my bottom number would be 8.
Okay.
All right. All right. So let's look at this next one. A fair coin is tossed 3 times. What is the probability that 2 heads and 1 tail are tossed? So remember from, I don't know if it was last section, might have been the first section when we created the tree that gave us our 2 options every time we perform the experiment. So we can do the same thing here, in which we want to see all of our options for rolling, or not rolling, but flipping the coin 3 times. So we start off with the first option. When I flip it, if it lands on tails, then from there, it could go from tails to heads, and then from there, tails, heads, tails, heads. And then we also explore the option of if I land heads first, second, it could be tails or heads, third, tails or heads, and then tails or heads after you flip heads. So we look at all of our scenarios. We got tails, 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 heads, tails, heads, tails, tails, heads, heads. If I can get it all. Next one, heads, tails, tails, heads, tails, heads, 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 tails, and heads, heads, heads. So those are our 8 scenarios that could occur. And the easiest way of figuring that out is by creating this tree for ourselves, making sure that we don't miss a scenario. All right. So our sample space, the number of our sample space will be 8, like I mentioned, 8 possible outcomes. And I boxed in our event. Remember, our event is 2 heads and 1 tails. So we have the possibility of doing tails, heads, 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 tails, heads, and heads, heads, tails. Those are 3 scenarios in which we get 2 heads and 1 tail. So before we finish off the problem, any questions? All right. So since we have 3 outcomes that produce the 2 heads and 1 tail, the number of our event is 3. And then place the 3 over 8, and that'll be our answer. That's our probability. All right. And as always, if I scroll up too quick and you still copying, let me know. There's no way that I can actually see you guys. So, yep, let me know. So the next one, two fair dice are tossed. What is the probability that the sum of the pips on the upward faces of the two dice equals 8? So just like before, the first thing we want to do is establish our sample space. So when we look at what's going on, what I tried to depict right here, the scenario is you have two dice, die 1 and die 2. So you want to figure out what are all of the possible outcomes, or the number of possible outcomes that we could have. You're talking about die 1 being 1, then die 1 being 2, die 1 being 1, die 2 being 2, die 1 being 1, die 2 being 3, and so on. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, go all the way down, then die 2 being 2, and figure out all the scenarios. So the easiest way of doing that is recognizing how many options I have for each die. And that's what we did over here. We have 6 options for each die. And so all you have to do really is multiply those 6 options to each other, and you have 36 possible outcomes. So if by some chance you had one die had 6 faces and the other die had 10 faces, 6 times 10 would have been 60 possible outcomes. And that goes back to our fundamental counting principle. So when we have 2 die and both of them have 6 faces, 6 times 6 gives us 36 possible outcomes. All right. So then we want our 2 dice to equal 8. So we're looking at here, when die 1 is 2, die 2 is 6, then 3 and 5, 4 and 4. And remember, die 1 being 3 and die 2 being 5 is not the same as die 1 being 5 and die 2 being 3. So you have to reverse them. And then the same thing is 6 and 2. So we have 5 possible outcomes. And since we have 5 possible outcomes, then you place the 5 over 36. And that's your answer. All right. Questions before we go to the next one? All right, calculating odds. Odds in favor of event E. You take the number of favorable outcomes and place it over the number of unfavorable outcomes. Then odds against E, you take the number of unfavorable outcomes and place it over the number of favorable outcomes. All right, so once again, it's odds in favor and odds against. So if a pair of dice is rolled once again, we have our pair of dice. What are the odds in favor of rolling a sum of 7? So make sure you pay attention to the directions and the questions that are being asked, because we're not talking about probability, we're talking about odds in favor. So we have to use the relationship that I just introduced. So we know The number of outcomes in your sample space is 36. Talking about rolling a 7. So here are our outcomes of rolling a 7. So we have 6 different ways that we could roll a 7. And those 6 different ways will represent the number of favorable outcomes. All right. So that means the number of unfavorable outcomes would be our sample space 36 minus 6, the number of favorable. And so the number of unfavorable outcomes would be 30. And then 30 plus 6 would give me my total number of outcomes. But the number of favorable outcomes would be 6. The number of unfavorable outcomes would be 30. All right. So odds in favor, you take the number of favorable outcomes, which is 6, and place it over the number of unfavorable outcomes, which is 30. Reduce if possible, which is 1 over 5. Any questions? All right, last thing in this section, relationship between odds and probability. All right, suppose E is an event in the sample space and the odds in favor of E are A over B. And you calculate the probability as A over A plus B. And I underline the odds in favor, make sure that you pay attention to that. And it says suppose E is an event in the sample space, the odds in favor are the probability over 1 minus the probability. All right. So let's look at this. I believe last example. Yep. That would be good for today. In 2010, the racehorse Drosselmeyer, yeah, that might look a little messy, but Drosselmeyer won the Belmont Stakes, beating the favorite Icebox. The odds against Drosselmeyer winning, Drosselmeyer winning, probably should have been winning instead of winner, but anyway, winning were 12-1. What was the probability of Drosselmeyer winning the race? All right, let you write that, and then we'll go a little further. All right, so the odds against is 12-1. But if you want to know the probability, remember the connection between probability and odds. Let's go back to our relationship, is odds in favor. So odds against is 12/1. That means odds in favor is 1/12. So you're just flipping them. Remember, that's the relationship between the two. You just flip them. And if that's the case, now that you have it in odds in favor as 1/12, go back to your relationship. It says that the probability will be A over A plus B. Your top number is A, bottom number is B. So that's 1/1 plus 12, which is a 1 out of 13. So the probability is a 1 out of 13 chance. All right. Questions, concerns, or comments? All right. We still have a little time, but I'm not going to go any further because remember I said we only have one more section left, which is 12.4. And then after that, we'll close out. We're closing out chapter 12. So there's no real rush. So we can say 12.4 for next class. So before we close out today, questions on anything? All right. So make sure you're knocking out this homework and the test that I have put into WebAssign. Don't forget any test that you have to send me your scratch work. Any test that you have submitted to send me your scratch work. You can take a picture of it or scan it, send it in an email, whichever way is fine. Outside of that, I will see you guys on next class. Have a good one.